Unit 6, PenHoff, Quantum and Qualia. Section 1, Qualia and Space-Time. The most developed quantum theory of consciousness is that of the theoretical physicist Roger Penrose and the anisotologist Stuart Hamerhoff, often abbreviated as PenHoff. They claim that consciousness derives from deep-level, fine-scale quantum activities inside cells, most prevalent in the neurons. While mainstream theories assert that consciousness emerges as the complexity of the computations performed by cerebral neurons increases, PenHoff posits that consciousness is based on non-computable quantum processing performed by qubits formed collectively on cellular microtubules, a process significantly amplified in the neurons. A qubit is a unit of quantum information, the quantum analog of the classical bit. A qubit is a two-stage quantum mechanical system, such as the polarization of a single photon. Here, the two states are vertical polarization and horizontal polarization. In a classical system, a bit would have to be in one state or the other. However, quantum mechanics allows the qubit to be in a superposition of both states at the same time, a property which is fundamental to quantum computing. Microtubules are part of the structure of all cells, but according to PenHoff, in neurons, their tiny inner spaces provide the shelter from high temperatures and other disturbances necessary for quantum coherence to take place. Penrose and Hamerhoff initially developed their ideas separately and later collaborated to produce PenHoff in the early 1990s. Penrose's argument stemmed from Gödel's incompleteness theorems. In Penrose's first book on consciousness, The Emperor's New Mind, 1989, he argued that while a formal system cannot prove its own inconsistency, Gödel's unprovable results are provable by human mathematicians. He took this disparity to mean that human mathematics are not formal proof systems and are not running a computable algorithm. According to a number of theorists, this line of reasoning is based on a fallacious equivocation on the meaning of computation. Penrose determined wave function collapse was the only possible physical basis for a non-computable process. Dissatisfied with its randomness, Penrose proposed a new form of wave function collapse that occurred in isolation and called it objective reduction. He suggested that each quantum superposition has its own piece of space-time curvature, and that when these become separated by more than one Planck length, they become unstable and collapse. This process creates proto-consciousness. Penrose suggested that objective reduction represented neither randomness nor algorithmic processing, but instead a non-computable influence in space-time geometry from which mathematical understanding and, by later extension, consciousness derived. Penrose's proposal that non-computable processes are important in higher mathematics and other conscious activities represents a radical rejection of the computational theory of mind and consciousness. As David Rose says, Penrose argues against our ability to simulate consciousness on computers. There are mathematical theories which state that certain problems are undecidable. Some puzzles cannot be solved ever in principle. Penrose suggests that we cannot even write, let alone solve, a mathematical description of consciousness because this is one of those problems. You couldn't even simulate consciousness on a computer because the mathematical problems at the quantum level are undecidable. Thus, the idea of functionalism, that you can simulate consciousness on a computer, is excluded. Rick Grush and Patricia Churchland, in a critique of PenHoff in the Journal of Consciousness Studies, characterize Penrose's mathematical ideas as Platonist. They ask whether there are any alternatives to a Platonist ontology of mathematical objects, abstract, immutable objects, truths, numbers, etc., and its usual companion, an a priori epistemology of mathematics, grasping with the intellect the absolute and immutable truths in Plato's heaven. Their answer is yes, evolutionary biology. They argue that evolution is a satisficer, not an optimizer. In other words, when designing organisms, evolution is happy with approximately accurate or accurate for most of the likely cases, rather than aiming for some abstract Platonic perfection. Grush and Churchland then say that how humans come to have the conceptual and cognitive resources to develop formal systems, proof theory, and mathematical certainty is a puzzle, though not perhaps more intractable than how we have the resources to read and write, to compose and play music, to skate, hang glide, and perform eye surgery. The idea, therefore, that mathematical capacity is an independent faculty of pure reason, whose exercise yields mathematical or any other absolute certain knowledge, by virtue of intuitively grasping propositions and objects in Plato's realm, is wanting in biological plausibility. There may be an alternative interpretation of the concept of consciousness as an independent faculty of pure reason, which we will look at later. PenHoff's basic thesis is that consciousness arises from the orchestrated objective reduction of quantum superpositions. The word orchestration in this phrase refers to a process through which, according to PenHoff, connective proteins associated with microtubules influence or orchestrate the quantum state reduction. This speculative idea is based on Penrose's particular interpretation of quantum mechanics. They posit that these reductions occur within the microtubules of neurons. As Gray puts it, PenHoff claims that the system of microtubules in neurons is the only one in the natural world likely to provide conditions for objective reduction of quantum superpositions. In this way, the theory manages neatly to find proto-consciousness in the very fabric of space-time while yet limiting full-blown qualia to just those systems' brains where we know them to be housed. In other words, PenHoff claims that proto-conscious qualia are embedded as quantum superpositions in the fundamental geometry of space-time at the Planck scale. When a superposition of quantum states self-collapses, i.e. objectively collapses, into just one of many possible states, that particular state becomes fully conscious. The other states into which the quantum function did not collapse had the capacity to become conscious, but they did not. They were merely proto-conscious. Geoffrey Gray comments that, consequently, we should find proto-conscious qualia wherever there are quantum superpositions. It turns out, however, that this prospect is a lot less panpsychic than it seems. Proto-consciousness may be everywhere you look, but not consciousness itself. PenHoff stipulates that only quantum superpositions which remain isolated long enough to reach threshold for objective reduction are conscious. This is a fairly stringent requirement met only in the brain and perhaps nowhere else.